if you wanted to show that a squared plus b squared has a constant value, you understand what they're really asking you to do is prove how a squared plus b squared is definitely going to be equal to a specific actual number that doesn't change, using this information over here. Does that make sense so far? And don't make the mistake of thinking like this is going to be much more complex than it needs to be, like, because it looks relatively advanced over here, like it's not a very typical expression you see, but what's really happening over here is, in order to prove a squared plus b squared, at the end of the day, what happens over here is, do you understand, if you square this and square this, that's how you're going to introduce a squared and b squared, because right now, as is, you understand, all you have so far is a to the power 1, b to the power 1, like there's no a squared or b squared component yet. That's why you have to square both sides. Both of these need to be squared, because otherwise you're not going to create anything with an a squared or a b squared. So without further ado, you just square that and square that. And also another clue over here is you'd have the awareness. In the actual exam, think about it this way, right? If you have a squared plus b squared, if you have sine x and cos x, you're not going to be able to prove a squared plus b squared equals to an actual number by the looks of it, as is. Because you're going to have a sine and a cos component in there. In order for a squared plus b squared to equal an actual number, you have to find a way to get rid of the sine and cos. And do you understand the only way sine and cos disappear is when you have sine squared plus cos squared? That's what they're really testing you on, isn't it? Yeah, so without further ado, that should be more than enough clue for you to just feel convinced that sine squared and cos squared is the right way to go. So you go ahead and square sine, and you go ahead and square cos. So this is where we have the expression sine squared equals to this, cos squared is equal to this. This is just doing the basic algebra so far. And realizing that if sine squared is equal to this, and cos squared is equal to this, then doing sine squared plus cos squared is going to create a 1, isn't it? Which is the same thing as doing this plus this. And you can see how it perfectly cancels out into 2a squared plus 2b squared equals to 1, which is the same thing as factorizing equals to 1. A squared plus b squared, we ended up with an actual constant over here. So we did that for part 1. Part 2, tan x equals to 2. My point is, if tan x is equal to 2, and this is all you have so far, you want to find a in terms of b, you need to find some sort of equation connecting a and b. And obviously for this question over here, tan x equals to 2 is using this information over here. You realize tan can only be expressed using sine over cos. So this is where we have sine over cos, and we know sine over cos is a plus b over a minus b. Just by definition over here, this is common sense stuff, right? The logic over here, the logic over here. So a plus b divided by a minus b equals to 2. Isn't that just going to be, we can definitely rearrange for a in terms of b now, can't we? It's about recognizing, hey, when you get to this step, which was very intuitive to do, because there's only one option tan x can be over here that involves sine and cos, and you know you have to involve sine and cos, is my point. Explain the logic process here. And that's how you know to do sine over cos, to create this component, which in order for a in terms of b, it means a in terms of a equals to what using the only letter b, which you can solve using basic algebra over here, because fraction is not as preferable as a non-fraction, cross multiplied, right? 2 times a minus b is the same thing as 2a minus 2b, which is what we have over here, right? This to that side, and then rearrange for b. B to that side, a to that side. You get negative a equals to negative 3b, which is a is equal to 3b, is the answer.